Hello and welcome to the YouTube channel D Creations Resources. We are talking about different concepts from science, maths, etc. And currently we have been talking about concepts from spectroscopy. So today let us talk about internal degrees of freedom. And this is basically an important topic when you talk about molecular spectroscopy. So the molecular motion that results from characteristic vibrations of molecules uh, is usually described by the internal degrees of freedom. So, what are these internal degrees of freedom? Now, if you consider a molecule with n number of atoms, so then each atom is going to have 3 degrees of freedom pertaining to its motion in the x, y, and z direction. So we said that the molecule has n number of atoms and each atom has 3 degrees of freedom. So obviously total degrees of freedom are going to be 3n. Now amongst these 3n degrees of freedom, there are going to be 3 degrees of freedom which are allocated for translation, while there are going to be 3 degrees of freedom which are allocated to rotation. So 3 plus 3 is 6. So if you subtract these 6, then the remaining 3n minus 6 degrees of freedom will be corresponding to motions such as changing the distance between the atoms or changing the angle between the bonds. Now, I would also like to point out here that when we are saying that there are 3n minus 6 degrees of freedom, we are talking about a non-linear molecule. If it is a linear molecule, then there are only 3n minus 5 degrees of freedom. Now let's take example of some common molecules. The simplest example is that of water, H2O molecule. So how many atoms are there? 2 atoms of hydrogen, 1 atom of oxygen. So total 3 atoms. Now it's a non-linear molecule. So the degrees of freedom are going to be 3n minus 6. So in place of n, we will put the number of atoms, which is 3. So 3n minus 6 is basically 3 into 3 minus 6. So 9 minus 6, which is 3. That means a water molecule has 3 degrees of freedom. So these 3 vibrations correspond to an in phase or symmetric stretch. Then second one is out of phase or asymmetric stretch. And the third one is a deformation or bending vibration. Now let's take example of some other molecules. Now let's take a linear molecule. Say H2. So how many degrees of freedom will it have? So 3 into 2, because now there are 2 atoms, minus 5, because we just saw that for a linear molecule there are 3n minus 5 degrees of freedom. So 3 into 2 minus 5, which means 1. So there is only 1 degree of freedom, and it basically corresponds to a simple stretching vibration. Now please notice that even for other diatomic molecules, linear molecules like N2 or O2, the degrees of freedom are again going to be the same because the number of atoms is 2. So 3 into 2 minus 5. So in each case, like whether it's H2 molecule or N2 molecule or O2 molecule, so any of the gases, hydrogen, nitrogen, oxygen, the degrees of freedom is just 1, and that basically corresponds to a simple stretching vibration. Now, how about a linear molecule with more than 2 atoms? So let's consider the example of carbon dioxide. So how many atoms are there? 1 atom of carbon, 2 atoms of oxygen. So 3 atoms in total. And it's a linear molecule. So the degrees of freedom is going to be 3n minus 5. So n here is 3. 3 into 3 is 9. So 9 minus 5, that means 4 degrees of freedom. So what do these 4 vibrations correspond to? Well, there's in phase or symmetric stretching, there's out of phase or asymmetric stretching, and there are 2 mutually perpendicular deformation or basically bending vibrations. Now these are called the normal mode of vibrations. For these vibrations, the Cartesian displacements of each atom in the molecule will change periodically with the same frequency and go through equilibrium positions simultaneously. So the center of mass does not move. The molecule does not rotate. So now on your own you can try to take some more examples of molecules and try to find out the degrees of freedom that they will have, and please note in every case that whether the molecule is linear or non-linear, because if it is a non-linear molecule then the degrees of freedom are 3 and minus 6, where n is the number of atoms in the molecule, while if the molecule is a linear molecule the internal degrees of freedom are going to be 3 and minus 5.